Hello everyone, my name is Srikriti Reddy and today I'm here to explain you the chapter Fun with Magnets in our physics lesson. So, magnets, they were probably discovered by Greeks. So, who are they discovered by? They're Greeks. By a Greek shepherd named Magnes. Let's be clear with one thing. This was discovered by a Greek shepherd Magnes, yes, because he went to nearby mountains to graze his animals. When he found that he had a stick, he had a stick like this which had a iron tip. This was an iron tip which avoids the wear and tear of the stick as it is made up of wood. He used to rest on a rock. For suppose if this was a rock and this was a tree, he used to rest under a tree sitting near a rock. He found that this stick's iron base tip got attracted to this rock easily. So by discovering that this rock which was there was named as magnetite after Magnes. So magnetite, nothing but this helped in finding directions. This was used as a navigational tool or a navigational compass. As this was a navigational tool, again this word magnetite was renamed as lodestone. Lodestone means nothing but guiding stone. So this is the meaning of lodestone. So we can call this magnetite as magnetite or lodestone. So this rock is actually made up of iron oxide, from which it has the property of attracting materials. Again, we humans found how to make magnets from magnetite. So yes, so if this has how we made magnets from magnetites, but there are two types, that is natural magnets and artificial magnets. Natural magnet means it is a natural occurring magnet, like here we saw this rock which is magnetite. Magnetite can be taken as an example of natural magnet. And we are coming into artificial magnet. As I said, the humans started learning how to make magnets out of small piece of iron and a little mix of magnetite. We made artificial magnets in different shapes and sizes. That is horseshoe magnet, like horseshoe magnets, bar magnets, ring magnets, etc. There were different kinds of shapes of magnets in artificial magnets. Now we are going to learn some materials. So yes, now we understood how magnetite is formed and how we make magnets out of wood and how this rock is made. Now I am going to introduce, like those words are magnetic, that is magnetic materials. Magnetic materials means the materials that can be attracted, the materials that can be attracted by magnets. These are magnetic materials. What about non-magnetic materials? Non-magnetic materials is opposite. The materials that cannot be attracted to magnets are called as non-magnetic materials. So I will just write the definition here, but remember that these materials cannot get attracted to a magnet. So now let's think of some examples. Examples are rubber, yes, plastic and wood, copper, even aluminium. But when it comes to magnetic materials examples, we can take iron, cobalt and nickel, and any other alloys, like any mixtures of those three materials. So here examples we took is rubber, plastic, etc. And here like iron, cobalt, nickel. So now these magnetic materials are there. Okay. Now what is the definition of a magnet then? Magnet is defined as a substance that has the ability or the property of attracting materials like iron, cobalt and nickel. Is it okay? Yes. Now we will learn some more words that are related to magnets. Now I'm going to show you a picture. I want you all to see this. This is a bar magnet. Think. This is a bar magnet, and here comes another bar magnet. So these both magnets, they are going to be attracted with each other, right? Just now I said that magnets can attract each other, or iron, cobalt and nickel, any magnetic materials like that, they can also attract other magnets. So if they attract, there is a process of attraction going on, right? Yes, this process of attraction is called as magnetism. Yes, this word is magnetism. The process or the phenomenon of attraction between two magnets is called as magnetism. Like here, when these magnets are attracted everywhere around them, whatever force, like whatever the phenomenon which is going to be occurred is called as magnetism. Magnetism of magnets. Next comes, let's take the example of bar magnets here itself. Next word is magnetic field. So here magnetic field means two magnets are there and they are going to exert some kind of force. They're going to exert some kind of force, like for suppose think you are catching this magnet with one hand and you are catching this magnet with the other one, and you can understand that to get attracted here, they use some kind of force. At that time you can experience some force, right? Yes, that force is called as magnetic force, the force which is exerted by the magnetism by the magnets. So next comes magnetic field. And now let's take the example of a bar magnet with a magnetic material. Now think here is a metal that is made of iron. So this bar magnet which is there here, it is actually going to be attracted to the iron, yes. But the magnetic force they will put on, we understood that the phenomenon of the attraction is magnetism, and they exert some force that is called as magnetic force, yes. We understood that also. But what is this magnetic field? It's kind of bit of tough to learn. Yes, but this can be easy when you understand this magnet or the other magnet, whatever it is there. That's a field, like whatever there, like the surrounding around the magnet. Here, if you see, if this is the magnet, the force whatever is getting exerted around the magnet, the force or the magnetism or the magnetic force can be experienced. So in which you put another magnet where the both magnets are going to be attracted, don't they? Yes, but this is where the magnetic field is there, where the phenomenon of attraction of magnetism is there, and a magnetic force, the ability can be experienced. So this three words that are important: magnetism, magnetic force and magnetic field. So the field, whatever the magnetic force and everything can be experienced, is called as magnetic field. Is that clear now? Yes. Because now I am going to introduce you some word of activity to introduce you another topic, that is poles of magnet. Poles of a magnet is a very important topic to learn. It's a very important topic to learn for us. So what are these poles of magnets? We will understand it through an activity. Now I will be showing you a diagram for that. See, this is a bar magnet. Imagine. Now, here, imagine as if this is magnetism, whatever the magnetic force is going towards this iron fillings. These are all iron fillings. Some chalk powder kind of thing. They are these iron fillings. And now as these are made up of iron, they will get attracted to this magnet, right? Yes, we all know that it will get attracted to the magnet. Yes, absolutely yes. But the thing is that if you observe or like think, if this is a bowl of iron fillings or some place where you kept all of these iron fillings are there and you dip this bar magnet here, then is there any miracle that appears? You can observe, now pick the magnet slowly out of those iron fillings. Then you will observe somewhat like this, if I'm right. Yes, all these iron fillings are going to be attracted here. They are right here like this, with funky thing, and those are nothing but the iron fillings. Where are they attracted to? Yes, these 2 points. What are they? That is where the magnetism, whatever the phenomenon of attraction, means the magnetism or whatever the magnet attraction that is going to take place is only higher, maximum at these 2 ends of magnet, nothing but the 2 ends of magnet. And now the 2 ends of magnet. Please, now let me tell you about the 2 ends of magnet. Those are not simply called as the 2 ends of magnet. They are called as the poles of the magnet. Now you can say me, okay, they are the 2 ends of the magnet, but why are they specifically mentioned or why they are specifically called as poles of magnet? That is because there is another important thing to know, not just from this iron fillings activity. Now you understood that the magnetism or the maximum strength is only at the pole and 2 ends of the magnet. That is the poles of magnet. But why this poles of magnet name is given? This poles of magnet, it is given because there is an activity. If you freely align a magnet, for example, if you freely align this magnet, what happens, like just keep a stand here, align it, catch a thread through it. Yes, if you align, you can observe, like keep some pointer like this, keep a compass. Here is the magnetic needle. Yes, so here is the magnet. It always aligns to the north and south direction. It always aligns through this north and south directions. And what are these north and south directions? Aren't there north and south 2 poles of earth? Yes, these are poles of earth too. And they point out only to the north and south direction, which are actually poles. That's what these 2 ends are called as poles of magnet. Now by this activity and iron fillings activity, you get to know what are these poles of magnet. And I think this time we have to introduce another term called as attraction and repulsion. This might also be easy, but when you do the activity itself with your own naked eyes, you can experience this. Yes. Now let me be clear with the term attraction and repulsion. Now here I will draw the diagram of attraction and here the diagram of repulsion. What is going to happen? Just now we introduced the topic poles of magnet. Now let's go to like poles and unlike poles. What are these like poles? Like poles are when these poles are same, like north and north, south and south. Like from one magnet side, both the magnets are facing at one side. Okay, here it is south, here it is south, or here it is north, or here it is north. At that time they are said to be like poles. But when they are said to be unlike poles, is when this side magnet is north and here it is south, or here only it is south and here it can be north between these two magnets. So like this. At this time they are called as unlike poles, just like your like fractions and unlike fractions. And here these are like poles. So these are like poles and these are unlike poles. Now when the attraction occurs, everything depends on the like poles and unlike poles. Why? Now here, imagine there are two bar magnets here, and here goes another magnet. Okay, so first let's talk about the phenomenon of attraction. How does this attraction actually take places? This attraction takes places. How? Here when you put these two magnets and unlike poles are there, right? North and south. Yes, think here it is north and south, or here only it can be south and here it can be north. But anyway, the poles should be only unlike poles. As I just now I said you unlike poles. Yes, be clear with it. North and south, or south and north. Those are unlike poles. Clear? Yes. So these unlike poles attract each other. The phenomenon of attraction take places only when north and south poles are there, nothing but the unlike poles. But while coming into repulsion, here the magnets do not attract, or the two magnets, they do not attract each other. Why? Because at this time the poles of the magnet are like poles. So now you understood. If this is south and south, or not a north thing, but here the magnets, instead of getting attracted, they will move away, they will swing away, because they are like poles, and like poles do not get the magnets attracted, only the unlike poles do. So repulsion only takes places when like poles are facing each other, and attraction takes places when unlike poles are facing each other. At that time the phenomenon of attraction can be taken place. Now we can also be a show test of magnet. This comes a very important topic. Now what is this show test of magnets? I want to be clear with this topic first. This can be done through the repulsion practice. Repulsion process. Now why does this repulsion comes in the shoe test of a magnetism? Let me be clear. Shoe test of magnet. If you see a material, if you want to prove that material, as if you want to conclude that this material is a magnet or not, you use the process repulsion. Now here comes a funny and important thing, why do you use this repulsion? Why not attraction? Now let me be clear with it. Because repulsion, as you know, that like poles face each other, so they repel. But when it comes to attraction, magnets can attract the magnetic materials also, right? Yes, they can. Magnet can attract another magnets as well, and they can attract magnetic materials as well. Magnet can be attracted to magnets as well as magnetic materials. So at that time, repulsion, it occurs only when two magnets like poles are facing each other. Then this repulsion occurs. But attraction, it occurs with magnetic materials as well as the other magnets. This is what you have to be clear with. That's why this process repulsion is used. Then why not attraction? Why not attraction? I just now said you. That is because magnets can attract. Please remember this point, it is very important. Magnets can attract magnetic materials. Magnets can attract magnetic materials, and as well as they can attract magnets also. They can attract magnets and magnetic materials. That is the reason we do not use attraction. But if we go through repulsion, only two magnets can repel each other because like poles are facing. So that's what shoe test of magnet can be done only through the process of repulsion. I hope I am clear with this also. Now I want to come into a topic of a compass. That is, we can never isolate poles. Now we're discussing in detail about the poles of a magnet. So let's say that we cannot isolate poles of magnet. Now, why cannot we isolate the poles of magnet? What kind of thing are you using? You can make me crazy, but not exactly. This is isolate poles of a magnet is very important. Why? Why? Because if a magnet, it is found that if a magnet is broken into two pieces, other two pieces, these magnets behave as complete magnet. Look, the full magnet is actually broken in two small pieces of form. But what do? They act themselves as a complete magnet. It's not like the broken pieces of magnet. The broken pieces, they are broken pieces of a magnet, but they act as a complete magnet. That is what's special. And that too, they have their own north and south poles. Okay. So therefore, again they have the north and south poles. But again, if you want to still be so sure of it, break this again. There are other two pieces formed, aren't they? Yes, but again these small two pieces also act as a complete magnet, and they also again have their own north and south poles. So this is how we say that we can never isolate poles of a magnet, that is the north and south pole of a magnet. Now I will say, keep on saying this north and south pole, north and south pole, north and south pole, north and south pole. Now what is this north and south pole? Let me be clear with north and south pole. These are poles of magnet as well as poles of earth, aren't they? Yes, they are. So this is earth and this side is its north and this side is its south. While here comes the magnets. This side is the north, this side is the south. So these are, can't you see this axis which is slightly running away through the imaginary line is called where the north and south poles of the earth can be pointed, and same in the north and south can be pointed in a magnet. This axis is called as the geographic axis. Okay, now here's another term for us, geographic axis. I just want to explain the definition now. Let me be clear with it. Before that, I want to introduce another tool, that is, we already learned about navigational compass. Just now I mentioned here the compass, right? There is a navigational compass because there is a needle, a magnetic needle which is having a pivot here which can be freely moved on a pivot. This magnetic needle which is made up of magnet is actually carved in some shape, and as you know, magnet always points to north and south direction. So with the help of this we can also find the east and west directions also. Is that clear for you? Yes. So this is how magnetic compass comes. So in magnetic compass, do you agree with me that there is a magnet in it? Say me. Yes. Do you agree? Yes. There's a magnet, but it is carved in the needle shape in the compass. At that time, for example, think. Now, look, I belong to the country of India, and here is India. This India, I am standing at this point at my own state, Telangana, and I am catching this compass which is actually having a magnetic needle which is giving me direction, saying here north, south, and here goes west, and here goes east, and having some other points, and again for south direction there is another point. Like this it is there. Let me tell you, just now we learned the process of attraction and repulsion, didn't we? Yes, there we understood that only unlike poles attract each other, while like poles they repel each other. The process of the phenomenon of repulsion takes place. So if you are standing here and north is facing here, does that mean that here your north pole here and here will get attracted? But look here, those unlike poles and like poles only repel each other. They do not attract each other. So that means that at that time your north is the south of yours. North of earth is the south of yours, and south of earth is the north of yours. Now let me be clear with another thing. Here is earth. Yes, and here is your magnetic needle in the compass, which is pointed here. Here is your north and south pole of earth. But remember that the south pole of your compass is actually the north of earth, and the north which actually your compass points is the south of this earth. Why? Because the like poles when they face, they repel, they do not attract. So unlike poles attract. So the process of attraction and repulsion phenomenon is very important while we compare the north and south pole of the earth as well as the north and south pole of the magnet. I hope you all understood. Like that, I just need one more thing to be told, that is earth is acting as a magnet. Here now it's having a north and south pole. Okay, why is it having a north and south pole, and why do we even need to mention these poles on earth? Yes, because there are layers of earth, and the inner core which is there, it is made up of molten iron. It is made up of molten iron, which is a magnetic material and acts as a magnet. So that's why earth can be treated as the giant magnet, of course. So here I am done with introducing you the earth as a giant magnet, as well as the navigational tool, nothing but the navigational compass which we use. So this is the part 1 and the end of today's topic. I hope you all are clear. Thank you.